Okay, these are problems from Homework 4. This was a P3, and these were multiples of 3. And hopefully you checked your answers and tried these. So let's take a look at these. And first one was a negative. The square root of 36. Well, the square root of 36 is just 6, so we have a negative. So we're taking the negative square root. Number 6, the square root of negative 25. Well, we cannot take the square root of a negative number. There's not a number that when we multiply it by itself, we get a negative. Positive times a positive is a positive, a negative times a negative is a positive, so it's not real. So that's all you would have to put for number 6. Number 9, the square root of 25 minus the square root of 16. Well, we simplify both these. The square root of 25 is 5, the square root of 16 is 4, 5 minus 4 is 1. Okay. Okay, now number 12. Okay, the square root of negative 17 squared. Now remember, we had a rule that if we're taking the square root of a number squared, or the square root of or the square root of any even power, that's just going to be the absolute value of the number, so that's just 17. Or if you wanted to work this out, you could say negative 17 times negative 17 is positive 289. The square root of 289 is 17. You could do it like that, but if you use this rule, it's just going to be absolute value. Now, if that was odd, it would just be the number. Okay? If this was the cube root of negative 17 cubed, it would just be negative 17. So take a look at that rule. We went over that in class. Now, they gave you a stipulation that x was going to be non-negative numbers, non-negative real numbers, which means x is going to be greater than or equal to 0. So remember that, because this applies to, some of the problems here we're going to be talking about. So this was our problem of 45x squared. So what I do is I try to separate that into the perfect square factors. And the perfect square factor of 45 was 9, and x squared is a perfect square. And what's left, if I divide 9 into 45, I get 5. And then I break this up. Remember, the square root of a product is the product of the square roots. And the square root of 9 is 3, and the square root of x squared is x. And what's left is just the square root of 5. Now, if we didn't have this stipulation, if we didn't know whether x was positive or negative, then we would have to put an absolute value bar here. But since they tell you that it's going to be a positive number, you don't need that absolute value. I think that was maybe a misprint in the answers. Okay, number 18, the same idea. Again, x is positive. So if I look at it, now neither of these can be simplified, but then if I kind of reverse this rule, in other words, the product, the square roots is the square root of the product, and put these together, then I can combine them, and 10 times 8 is 80, and x times x is x squared. Now I've got some perfect square factors. 80, 16 goes into 85 times. So a perfect square factor of 80 is 16, and there's the 5, and there's the x squared. So this is my perfect square factor. I didn't have room, otherwise I would have written an extra step like this, but the square root of 16x squared is just 4x, and then I have the square root of 5. And you could skip that step anyway. You can go from there to there. Okay? Okay, here's number 21. And in the same respect, I've got the square root of 2x squared times the square root of 6x. So this would simplify, but I can combine these anyway and then simplify it later. So I got 2 times 6 is 12. So I just wrote it out. Remember, the product of the square roots is the square root of the product, so I put them all together. And like I said, some of this is redundant. I could have taken the x squared out over here. 2 times 6 is 12, so I got 12x cubed. And then I broke it up into perfect square factor. In other words, 4 and x squared are the perfect square factors, and what's left is 3x. And if you multiply this, you get the 12x cubed. But this is a perfect square. What's the square root of 4x squared? 2x. And what's left is a 3x. So this comes out to here. Okay? And that was number 21. Kind of worked over here. And here's number 24. And the square root of 1 over 49. Remember, that violates one of our no-nos. We can't have a square root under, we can't have a fraction under the radical, so I break it up. Remember, the square root of a quotient is the quotient of the square roots. So I have the square root of 1 over the square root of 49, and the square root of 1 is 1, and the square root of 49 is 7. So that worked out nicely. And again, here we have a radical in the denominator, so we want to take care of that. That again violates one of our no-nos. Just like up here in these previous problems, we couldn't have perfect square factors under the radical. Here we can't have a radical in the denominator, so one way to do this is to combine them, because I can use a little foresight. I see that 3 goes into 48, and this will simplify, so I'm going to kind of make this the quotient of the square roots is the square root of the quotient, so I can simplify, because 3 goes into 48 16 times, and then x cubed over x leaves me with x squared. And now I've got a nice perfect square factor, and the square root of 16 is 4, and the square root of x squared is x. Now again, we know that we're told at the problems, if you look at the top at these problems, it says that x is greater than or equal to 0. So I don't need the absolute value bar. If I didn't know that, I'd need the absolute value. Okay, number 30. Again, it's very similar to number 27. I look ahead and I know that 3 goes into 24 evenly, so I'm going to make this, use the rule, the quotient of the square roots is the square root of the quotient, excuse me. All right, so the quotient of the square roots is the square root of the quotient, and then 3 goes into 24 8 times, and this cancels, leave me with x cubed. X to the 4th over x is x cubed. And then I can break this up into perfect square factors, and perfect square factor of 8 is 4, perfect square factor of x cubed is x squared, so I've got 4 times x squared times 2x. If you multiply this, you get that. And what's the square root of 4x squared? 2x. So this comes out to become 2x times the square root of 2x. Okay, hope that makes sense. I'll leave these up for you to see.